So now I am going to start with partial differential equation, finding the solution using by direct integration. Equations solvable by direct integration. We now consider such PDE, partial differential equation, which can be solvable by using direct integration. In place of the usual constants of integration, we must however use arbitrary function of the variable held fixed. See, generally after integrating we are adding constants, but here partial derivatives, differential equations. If you are integrating with respect to x, instead of adding normal constant, you add arbitrary function of y, because with respect to x means we are keeping y constant. So in that plus c plus c1 you add a function of y after integrating with respect to x partially. Suppose we are integrating partially with respect to y, instead of adding plus c you add, because of x variable keeping constant, so add after integrating with respect to y f1 of x or g of x, like that. Okay. So one example, solve dou square u by dou x dou t is equal to e power minus t cos x, given that u is equal to 0 when t is equal to 0 and dou u by dou t is equal to 0 at x is equal to 0, is solution. Dou square u by dou x dou t is equal to e power minus t cos x. So how to integrate? First integrate with respect to x. So while finding derivative, that is last to first variables, integration is the reverse process of differentiation, though first to last. What is first here? Denominator x variable, then next integrating with respect to t. Integrating with respect to x, keeping t constant. That means here the variable t fixed constant, okay, held fixed, keeping t constant. So dou by dou x, del by del x, and integration cancel, which gives del u by del t is equal to, with respect to x integrating means e power minus t constant, this is in multiplication which comes same position. That means integration will not affect on a multiplicative constant, okay, and cos x integration is plus sin x. After integrating, what we are doing, generally adding constant. Instead of adding constant, you add arbitrary function of this t, because keeping t constant here, okay, plus sum f of t, equation 1. So to get u, now we have to eliminate del by del t, that means integrating with respect to t. Integrating with respect to t, in bracket, keeping x fixed, because with respect to t, comma, so which gives u with respect to t integrating sin x constant, because it is multiplying, which will not change. Exponential minus t integration is minus e power minus t sin t, plus, because of integrating with respect to t, integral f of t, we don't know that value, dt, plus after integration we have to add the constant. Here x variable we fixed, so add some g of x, let us say equation 2, okay. Now what is one by one condition from the first here? Dou u by dou x is equal to 0 at x is equal to 0. Substitute this value in dou u by dou t, sorry. So dou u by dou t is equal to 0. At x is equal to 0. Substitute these value in 1. 1 gives 0 is equal to, x 0 means sin 0 0, so 0 is equal to plus f of t. That means f of t is equal to 0. Okay. And other condition, u is equal to 0, comma t is equal to 0, comma 2 gives 0 is equal to sin 0 0, and this is integral 0 dt plus g of x. So from this, so g of x is equal to some minus k. Integral 0 means constant. Constant I have taken k. So therefore 2 becomes u is equal to minus e power minus t sin t. What is integral f of t dt? K. Here I have taken integral f of t, or you can just write here integral 0, keeping like that. Integral f of t dt is plus k, g of x minus k. So this simplifies to sin t. Because f of t 0, integral 0 t I took minus. So this is an example whose solution is obtained by using integration, one by one integration. Integral 0 I took here k, so that g of x, this I have taken integration 0. Definite integral 0 means 0, indefinite integral 0 means a constant, that I took a constant k, so send this k into that side, becomes gx is equal to minus k. Next, variables separable method. It involves a solution, which breaks up into a product of functions where each function contain only one of the variables, that is independent variables. So just we have discussed variable separable in first order ordinary differential equation. Now in the case of partial differential equation, second order, any order, it's the solution starts with, breaks up into a product of functions where each function containing only one of the independent variables. Okay, so for example, your differential equation containing x and y variables independent, z is dependent variable, you start with z is equal to some x function into some y function, unknown functions, that is called product of functions where each function containing only one of the variables. Then substitute that value in the given equation, then which gives after simplification a solution. Okay, the following example explains this method. Solve dou square z by dou x square minus 2z dou z by dou x plus dou z by dou y is equal to 0. Del square z by del x square minus 2 times del z by del x plus del z by del y is equal to 0. Plus del z by del y is equal to 0. Here z is dependent variable, that is unknown function. After finding, it becomes a solution in terms of two independent variables x and y. So what I told? So first of all, given PDE equation 1. Okay, so you start with solution z is equal to product of functions. Here what are that variables, independent variables x and y. The x function I have denoted by capital X of x and the y function I have denoted by capital Y of y. So product of x terms alone and y terms alone. Okay, be the solution of 1. Okay, then What is del z by del x? With respect to x partial, y constant. So x derivative, f of x derivative just like f dash x, here capital X derivative, say capital X dash, because it is unknown right now, we don't know, we are going to find. Del z by del y partially with respect to y means keeping x constant, y derivative y dash, so x into y dash. And what is other derivative? Del square z by del x square, that means in the left side whatever the derivatives are there, that I am calculating using this assumption solution. Okay, del square z by del x square, that is, for this you find partially with respect to x, so y constant, x dash derivative is x double dash into y, substituting all these values in equation 1. So therefore 1 implies x double dash into y minus 2 times x dash into y plus x into y dash is equal to 0. Now express this equation as two simultaneous equation form, where that means express this equation in the form of LHS equal to some RHS, where LHS containing x terms differential equation and RHS containing y terms differential equation. So this can be written as x double dash minus 2x dash into y, sending this term to other side, minus x times y dash. Now it indicates separation of variables. Bring all y terms along with the derivatives on one side and keep x terms along with the derivatives on other side. So x double dash minus 2x dash by x is equal to minus y dash by y. Each is equal to some lambda, say. Because we don't know that value, I am saying each is equal to lambda. So here you will be getting two differential equations, equating this value to lambda, equating to this lambda. Two differential equations. One is second order equation, other is first order equations. Because of x derivative with respect to 2 times, with respect to y 1 time. Okay, depending on the equation only we can say how many different types of individual differential equations. What is individual differential equations? X differential equation only, not containing y. Y differential equation only, not containing x, like that. So this implies solve x double dash minus 2x dash by x is equal to lambda. Or you just write, instead of solve, consider. Consider. Now just bring all the terms to one side. This can be written as x double dash minus 2x dash minus lambda time x is equal to 0. So lambda is a constant, 2 is a constant. This is the second derivative with respect to x. Linear differential equation with constant coefficients, what we have solved so far before this. Okay, so what is auxiliary equation? M square minus 2m minus lambda is equal to 0. You know how to find the roots. Which implies, using quadratic equation, m is equal to minus b, that is plus 2, plus r minus b square, that is 4, minus 4ac, that is plus 4 lambda, divided by 2a, that is 2. So 4 is common in the square root. After taking out, then 2 is cancelled in all the terms, that is, it can be written as 1 plus r minus root over 1 plus lambda. So these are two different roots, 1 plus root over 1 plus lambda, comma 1 minus root over 1 plus lambda. So therefore solution. Let us say this is equation. All of you say first of all this is equation 2 solution. Equation 1 is given differential equation, and here one variable differential equation, linear equation in x. Equation 3, solution of equation 3. X is equal to CF because right side 0 in the third equation. So what is CF? m1 m2 roots c1 e power 1 plus root over 1 plus lambda into x, m1 m2 distinct roots, plus c2 e power 1 minus root over 1 plus lambda times x. Okay. Now minus y dash by y is equal to lambda. So this can be written as y dash by y is equal to minus lambda, integrating with respect to y, small y, because capital Y dash are functions of y. So it is in the form of f dash x by fx, whose integration is log fx. Log y is equal to minus lambda, constant integration with respect to y is constant into y plus some constant. After adding, after integration we should add constant. Since integral f dash x divided by f of x dx is equal to, what is the formula? Logarithm of f of x. Now after finding individual solution, then substitute in equation 2. So therefore 2 becomes, substituting these individual solutions in equation 2. What is equation 2? Z is equal to x of x. What is x? This is c1 e power 1 plus root over 1 plus lambda times x plus c2 e power 1 minus root over 1 plus lambda times x. This multiplied by, so here I can express y is equal to, after eliminating logarithm, that right side becomes exponential minus lambda y into some k, where k is equal to e power c3. Using logarithm properties, eliminate logarithm, e raises to right side, e power c3 I have taken some k. Okay. Now this is e power minus lambda y into k. So just merge this k into c1. K is multiplying with c1 and k is multiplying with c2. Take some other constants. This is equal to a into e power 1 plus root over 1 plus lambda times x plus b times e power 1 minus root over into x whole multiplied by e power minus lambda y is the required solution. Okay. Here a is equal to c1 into k, b is equal to c2 into k. Product of constants can be written as another arbitrary constant, because it is a second derivative problems, two arbitrary constants. So one x differential equations I used the method complementary function auxiliary equation, and the y solution I have evaluated using integration, because first derivative problem only one term is there. So this is given 2013 problem. What I am going to solve now. 2013, get which one of the following partial differential equations PDE cannot be reduced to two ordinary differential equations by the method of separation of variables. So let me explain. So far we have done one example by the method of separate variables. Independent variables x and y, z is dependent variable. That I brought into two differential equation, x differential equation alone, equation 3, y dash by y, that is y differential equation alone. So that is the called two ordinary differential equations according to the options, which is not reduced to the previous what I gave the example, two ODEs. Okay. A, dou u by dou t minus dou square u by dou x square is equal to 0. B, dou square u by dou t square minus dou square u by dou x square. Option C, dou square u by dou t square plus dou square u by dou t dou x plus dou u by dou x equal to 0. Option D, dou square u by dou t square plus dou square u by dou t dou x plus dou square u by dou x square equal to 0. Now what the question requires, in all these u is dependent variable, x t independent variables. Your first step is let u is equal to x of x into t of t. Then take one by one option, substitute that value, then you see that which is not reducible to two ODEs. I already done in the previous example, x differential equation alone, y differential equation alone. If you get it, that is reducible to two ODEs. If you do not get it, that is not reducible to two ODEs. Let u is equal to x of x into t of t be the solution. Okay. Now option A, PD is dou u by dou t minus dou square u by dou x square equal to 0. This reduces to, first of all, with respect to t means x dash, sorry, x constant, t derivative t dash. With respect to x, two times I have shown you the previous problem. Okay, minus x double dash into t is equal to 0. Now you show this is going to two ordinary differential equation or not. Otherwise, that is the option. Answer is this option. So this is reducible to x double dash by x is equal to t dash by t. So this is ordinary differential equation, and this is also ordinary differential equation is equal to lambda, a constant, say. Okay. T dash and x double dash divided by t OD. Next, option B, by dot t square, that is x t double. Okay, first of all, t is dou dot t square, yes, dou square dou is equal to 0. This simplifies to x into t with the help of assumed solution minus x dash into t. So this simple నిన్న అసలు రాలేదు. So this simplifies to x double dash divided by x is equal to t double dash by t is equal to lambda, say. So this is also first ODE and this is second ODE. Two ODEs, two ODEs. Okay, no problem. Option B is also correct. Option C, PDE is dou square u by dou t square plus dou square u by dou t dou x plus dou u by dou x. This simplifies to, okay, with respect to t, 2 times means x into t double dash plus 1 time t, other time x. So that is x dash into t dash. Okay, next dou u by dou x with respect to x only. So plus x dash into t is equal to 0. Okay. Now let us see, this is reducible to one differential, to one ODE or two ODEs or no ODE, like that. Here I can take x dash common. X into t double dash, sending the other two terms, and then after taking x dash, this becomes t dash plus t. Now easy to separate the variables x and t. So this simplifies to t double dash by t dash plus t is equal to minus x dash by x is equal to lambda, say. So this is ordinary differential equation and this is also ordinary differential equation. Okay, both are ODEs. So automatically option D is wrong. Okay. Option D. PD is dou square u by dou t square plus dou square u by dou t dou x plus dou square u by dou x square is equal to 0, which implies, substituting with this solution, this becomes x times t double dash plus x dash t dash plus x double dash into t is equal to 0. Okay. Into t. So here no x common, no t is also common. So this is cannot be cannot be reduced to ODE, ordinary differential equations. So answer is option D. Next one is general definition of second order PDE. A general second order partial differential equation will be of the form A of x comma y dou square u by dou x square plus B of x comma y dou square u by dou x dou y plus C of x comma y del square u by del y square plus f of x y u del u by del x del u by del y is equal to 0. Equation 1. Where u is a function of x and y, that is u is equal to u of x comma y. U is dependent variable, x comma y are independent variables. Second order PD, all the derivatives I have considered, but it doesn't mean that in every problem all these terms presented. Okay, some terms may missing. One of the derivative, highest derivative, second derivative present, then it is called second order PD. Okay. If b square minus 4ac greater than 0, then equation 1 is called hyperbolic PD. Hyperbolic PD. If b square minus 4ac is equal to 0, then equation 1 is called parabolic PD. parabolic PD. If b square minus 4ac less than 0, then equation 1 is called elliptic PD. So parabola, hyperbolic, elliptic PD. Second order hyperbolic PD, elliptic PD, parabolic PD. So A is nothing but del square u by del x square coefficient, B is nothing but del square u x by del x, del square u by del x del y, C is nothing but del square u by del y square coefficient. Just remember the second order derivative coefficients denoted by ABC. Find this condition greater than 0 is equal to 0 less than 0. Then options, look at the options, hyperbolic, parabolic, elliptic, none of these like this. Okay, just remember the first three terms of second order PD standard form. One example I am going to do. Example, which is given 2013, first one. The type of PDE dou f by dou t is equal to dou square f by dou x square is A. Parabolic, B. Hyperbolic, C. Elliptic, D. Non-linear. Just write here, erase, hyperbolic spelling is hyperbolic PD. Now instead of u it is given f variable, x is original, and instead of y it is t variable. Here the independent variables are x and t, the dependent variable is f function. Okay. Just compare solution. Here, if you consider this is the first derivative like this, A is equal to how much? 1. Bring all the terms to one side. So no other second derivative. B is equal to 0, C is equal to 0. Okay. F is dependent variable, x comma y are independent variables, which implies b square minus 4ac how much? 0. Therefore, the given PDE is parabolic. So observe the two independent variables and dependent variable unknown function and compare with our standard notation, then calculate, then find ABC, then find b square minus 4ac and decide the nature.